7.1.3, how can I find the rate? News reports use rates to provide important information. For example, when there is a sudden heavy rain, reporting the rate at which the local river is rising gives people a sense of how quickly it might flood. Sometimes rates are reported in words such as the pitcher struck out the batter after throwing the ball 92 miles per hour. Other times, the rate is provided in a graph or a table, such as the price of food over time or how rapidly a disease is spreading. Today, your team will develop strategies to find the rate in new contexts using tables and graphs. 7.23, maximum miles. The graph at the right compares how many miles are traveled to how many gallons of gas are used for two different cars. A, which car can travel the farthest on 5 gallons of gas? Which one travels the shortest distance using 5 gallons of gas? How is this found on the graph? So we're going to go over to the graph, right? And at 5 gallons, we can see that car B, nope, that wasn't straight. Okay, and I'm going to switch colors for car A at 5 gallons. Who went further? Car A or car B? Well, car A went further. So I used that theory of that slope triangle to find that. So car A travels further. Does car A travel the same number of miles with every gallon of gas? How can you tell? Did that line make a straight line? Yes. C. A third car, C, uses 6 gallons of gas to travel 120 miles. So 120 miles and 6 gallons. Make a table for the car listing at least 4 equivalent ratios of the gallons and miles and add those points to the graph. Well, it's already added on this graph here, so we don't need to do that. But we're going to continue these problems on the next page. So we have to think about car C as well now. Manufacturers often advertise the miles per gallon, or MPG, for cars they make. This measurement is the unit rate because it's the mileage for 1 gallon or unit of gasoline. Calculate the unit rate for each car. List the cars in order from the highest MPG to the lowest. So if we look at this graph, which is going to be the lowest? It's going to be car B because that line is the least steepest line. Car A is actually the steepest, so it goes the furthest on 1 gallon of gas. So I'm going to write A, C, B in that order so we know that's the highest to the lowest. And now we need to find it. So car C goes 120 miles on 6 gallons. Can we simplify that? Yes. So it goes 20 miles per gallon. Now we have to find A and B from the graph. It might be easier to use this graph than the other one. Because it has some grid lines on it. So car A, oh, I can't really read a lot of these points. So car A intersects here on this grid line. And it'll be an equal amount over here. So I'm going to use those two values. So that is at 6 gallons. And how far did it go? So if you looked at the graph, it's counting by tens, right? So that's 150, 60, 70, 80. So 180 miles on 6 gallons. And let's go down here and fill it in. Or 30 miles per gallon, right? 180 divided by 6. Somehow I don't think B is going to come out that easily. All right, let's look at B. It intersects right here. So that's at 6, 7, that's at 8. And how far did it go? 140. And that doesn't go in evenly. It gets approximately 7.5 miles per gallon. So we just found the unit rate and the slope at the same time. E says, how can the graph help us compare the miles per gallon of different cars? List the cars in order from the one with the steepest line to the one with the least steepest line. So we just did that. We don't need to do it again. I'm just going to draw the arrow. How can you use the graph to figure out which car has the best gas mileage? So we look to see which line was the steepest, right? Best means steepest. Okay. All right, you have some practice problems to do on your own.